Before construction begins, several factors should be considered. Make sure a market exists for the crop you want to grow. You will have to meet your buyer's strict requirements on variety, delivery schedule, quality, and other specifications. Since greenhouse production is more expensive than field production, you must make sure that you have enough capital to build and run the operation. Also, financial considerations will determine the type of greenhouse you build, the crop you raise, and the production systems used to cultivate it. Finally, you should conduct a profitability study and a cash flow analysis before you decide to begin construction. Many things come into consideration when choosing a location for a greenhouse. First, there are the physical characteristics of the site, the slope of the land, soil quality, potential shading, and previous land activities all influence the final decision. A clean, dependable water supply is essential. Plants require at least 3/4 to 1 liter of water per day in the early stage of their development. The volume of water used increases at the blooming, fruiting, and harvesting stages of the plant. Daily water requirements can reach up to 2 to 3 liters per plant at maturity. When calculating water requirements, remember that water is also required for cleaning of equipment, as well as the personal hygiene of the greenhouse staff. The next consideration should be the energy source. If electricity is going to be used, does the farm have access to the main power grid? And is the infrastructure to handle the power in place? With energy costs rising, electricity from the grid or an on-farm generator may not be the best sources of power for irrigation, fans, and cold room storage. Can gravity be used for irrigation? Is there room for solar or other renewable energy sources? Transportation of your crop to market is another important consideration because produce is extremely perishable. Do you have good access to roads and transportation? What is the distance from your farm to the market? Ideally, a communication system should be in place, whether it be landlines, cell phones, or internet access. Labor should be locally available and reliable. Are there potential security problems like theft of equipment and produce? If so, you may need to budget for guards during off hours. Whether security risks in your area are high or low, entrance into the greenhouse should be controlled. Greenhouse shapes are broadly based on either an arched or gabled design. Varieties of these designs include the sawtooth, the A-frame, and the gutter-connected gable. The gable or house shape is the most common greenhouse design. This design has a two-sided roof and comes to a point, the slope of which is determined by the precipitation load likely to fall on the greenhouse. The higher the load, the steeper the slope to allow for quick runoff. For high rainfall areas, a slope of 3:1 is sufficient. In areas of less heavy rain, a slope of 4:1 will do. That is to say, for every 4 meters wide, the roof goes up 1 meter in height. The Quonset, or arch-shaped design, includes the tunnel greenhouse. Originally designed for cool areas, this greenhouse is common everywhere because it is relatively easy to build. Tunnel greenhouses include macro tunnels, which are commonly built in warmer areas and are at least 5 to 6 meters in height. This height allows hot air to rise above the crops, protecting them from overheating. Smaller tunnels are built in cooler areas where a hotter growing environment is essential to plant growth and development. Depending on the needs of your area, you may include a zenith window in your greenhouse design. A zenith window runs the length of the greenhouse roof and allows for the escape of hot air. When determining placement, design, and the materials to be used in building your greenhouse, one must consider the force and direction of the wind and how frequently these winds occur. The design must protect from physical damage caused by strong winds. A greenhouse should be built to withstand gusts of 80 km per hour and higher, depending on its design. To help protect the greenhouse from strong winds, it is recommended that the farmer plant a fast-growing local species of tree, at least 20 meters from the greenhouse. The greenhouse must also be situated to facilitate passive cooling. Passive cooling occurs when wind blowing over the greenhouse pulls the hot air from the zenith window and pushes cooler air in through the sides. The greenhouse must be positioned so that the zenith window is not facing the wind. Air movement within the greenhouse is also important for plant growth, as it influences relative humidity and plant transpiration rates. Relative humidity should be around 60 to 70% for optimal growth. Once a greenhouse has been built, your next job is optimizing temperature and light. Temperature can cause problems for a greenhouse crop. Growth stops at 5 degrees Celsius, 41 degrees Fahrenheit. And protein is destroyed at 50 degrees Celsius, 122 degrees Fahrenheit. Excessive temperatures in either direction will hinder growth and flowering and eventually kill plants. In extreme conditions, plants will show symptoms such as wilting or freezing of external parts. Temperature influences respiration, transpiration, photosynthesis, maturation, root function, flowering, fruit ripening, and dormancy. For tomato, for instance, 15 to 30 degrees Celsius is considered the ideal temperature range for optimal growth. The difference in daily temperatures can also influence plant development. Optimum tomato plant growth occurs when the nights are around 5 degrees cooler than the day. Cooler nights slow plant respiration, which lowers biomass loss. If passive ventilation is not enough to reduce temperatures and humidity to acceptable levels, thermal screens or shade cloth can be used as a horizontal curtain to reduce heating. The greenhouse may also be cooled using exhaust fans, horizontal fans, cooling pads, and fogging systems. While these systems are effective, they can increase energy costs significantly. Light drives plant production. However, during the dry season, with solar radiation at its highest, the fruit and leaves of the plant may experience sun scald. If this is a problem, 30 to 40% shade cloth or the use of whitewash spray on the roof is recommended to reduce radiation. This amount of shading will not affect production in the summer months. During wet or winter months, the light entering the greenhouse may not be sufficient. To maximize light reaching the plants, the inside of the greenhouse should be painted white. Also, beds or ground surfaces can be covered with silver or white-colored plastic mulch. Actual load refers to the amount of pressure the greenhouse will have to withstand. This includes the dead load, which is the weight of the structure itself, and the live load, which represents the weight imposed on the structure by plants and equipment. Wind is another important load source that varies greatly and which needs to be factored in. To lessen the overall load, you can build a trellis system independent of the greenhouse structure. The trellis structure needs pole braces to ensure that it carries the full plant weight. Each tomato plant could bear up to 5 kilograms in fruit, plus a similar weight in fresh matter. Thus, a plant at harvest could weigh up to 10 to 15 kilograms. In a greenhouse measuring 600 meters squared, there could be as many as 1,500 plants, which would give a total plant weight of 22,000 kilograms. To increase the strength of a greenhouse design, the distance between support posts can be reduced. Reducing the distance between beams in the roof can also have a beneficial effect.